Okay, so today what we're going to do is we are going to be solving quadratic equations by completing the square. So you have already, you've already done this, right? You did this last year. And of course, this year we focused on solving quadratics, equations and expressions by factoring. Now it's going to become by completing the square. Okay, so let's look at this. So the first thing we're going to do is we're just going to look at an expression, right? This is not an equation. There's no equal sign. And we're just going to remind you guys on how to complete the square. Now, you've seen there are more methods than just this one. I've taught different methods. I taught a different method last year if you were my IM2 class. So there are different methods. I'm just going to show you probably the easiest one to memorize. Okay? So the first thing that we do when we complete the square is we identify b. So I have this quadratic. It's got to be a quadratic, right? It's got to be squared here on the highest term. And what we do is, again, we identify b. b is the number in front of x. So in this case, I think you guys would agree in this one, b is 4. Okay? Step 1, easy peasy, right? Just identify b. Next, for step 2, what we do is we take b, which is 4, divide it by 2, and square it. So I'm going to simplify that. 4 divided by 2 is 2, so this will become 2 squared, which is 4. And last, all you do is you add it to your expression. So I'm going to copy this. I've got this thing right here. So what I'm going to do is I'm going to get rid of c, because c is going to become 4. That's it. That's completing the square. Okay? That's the actual completing the square. Now we want to actually use it. So you complete squares when you have an equation. Okay, so this was just kind of like, here's the process. Now let's actually see how that process is used. Okay, so if you need anything from here, stop the video, grab it. But otherwise, we're going to move on. So let's see what we can do with this. Oh, let's get rid of that stuff. So let's see what we can do with here. So remember, step 1, we identify b. b is the number in front of x. So b equals 12. Next, we complete the square. So basically, we're identifying what c is, right? So just really quickly, quick reminder. So when we did this, what we were really doing when we found all this, we were finding c. So if you guys don't mind, what I'm going to do is I'm going to say, okay, well then c equals b, which is 12, divided by 2, quantity squared. So 12 divided by 2 is 6, so this is 6 squared, which equals 36. Okay, so it's always b divided by 2, quantity squared, equals c. We did it for an expression. Now let's actually use it the way it's meant to be. We're going to do this for some equations. So the idea here, when we complete the square, what we really want to do, and I'm going to erase this in just a second, is I want to add c to both sides. The reason is I'm trying to turn this left-hand side into a perfect square. Okay, once it's a perfect square, we can use a factoring technique in order to figure out to solve this equation. Okay, so again, you've seen this last year. This is just a reminder. So step 1, let's go find c. If you want, you can do it as scratch work. So for example, maybe off to the side, I just say c equals b. Remember, b is the number in front of x. So b equals negative 4 divided by 2, quantity squared. So negative 4 divided by 2 is negative 2. Negative 2 squared is 4. Now, because this is an equation, right? This is an equation. It has an equal sign. Because it's an equation, I can't just add that 4 to the left-hand side. In order to keep that equation balanced, I have to add it to both sides. So let's do that. So this is going to become, using finger paints. This becomes x squared minus 4x plus that c, which is 4, equals negative 3 plus 4. Okay? Next, we're going to simplify. So right-hand side, easy peasy, negative 3 plus 4 is 1. Left-hand side, okay? You can, if you want, if you're like, I don't remember how to deal with this is a perfect square, and I'll remind you how to deal with perfect squares. But if you're like, I don't remember how to deal with perfect squares, factor it, okay? We've talked about plenty of factoring. You can just go and factor this like you normally would. That's not a big deal. But what I'm going to do here is I'm going to do both, okay? So I'm going to remind you on how to identify something that's a perfect square, and then what I'm going to do is I'm going to factor and show you how I can use that. So reminder, how do we determine something's a perfect square? We look at the first term, we ask ourselves, is this a perfect square? Yes, because x times x equals x squared, perfect square. Is this term a perfect square? Yes, it is, because 2 times 2 equals positive 4. The next thing we do, and this is the hard part for you guys, is if we take 2 times times the square root of the first, which is x, times the square root of the second, which is 2, do we get the middle term ignoring the plus or minus? And I think you guys would agree we get 4x. If that is true, which it is in this case, then we get the square root of the first, sine of the second, square root of the last, quantity squared. Okay? I'm going to finish this up, and then I can show you how we could have used factoring in order to finish that up. Okay? So from here, I'm going to take the square root of both sides. So I get x minus 2 equals, when we take the square root, we get plus or minus. That's a reminder from last time, right? We get plus or minus the square root of the right-hand side. So this gives us x equals, adding 2 to both sides, 2 plus or minus 1. So what does that mean? That means x equals 2 plus 1, which is 3, or 2 minus 1, which is 1. Okay, now let's backtrack just for a second here. Let's go to how could I have used factoring to deal with that? Well, what I could have done, I'm going to give myself a little space, so I'm going to remove that. What I could have done, so let's we'll call this like method 2. So here I am, and I want to solve this. Negative 3 plus 4 is 1. How could I have done that? Well, we could have factored, and what we would have done if we had factored, as you guys know, is we would have gone x minus 2 times x minus 2 equals 1. Notice, we have the repeated factor, something times itself. This is the same thing as this squared, okay? Which would have brought us right to here. Okay, so you could have used factoring if you prefer, if you have trouble recognizing perfect squares. But again, recognizing perfect squares is important. You should be good at that. Okay, see what you can do with this one. Pause the video and do it. Okay, I'm going to catch up with you guys, so let's go find out what that c value is. So c equals b, which is 16, divided by 2, quantity squared. So 16 divided by 2 is 8. 8 squared is 64. So I'm going to be adding 64 to both sides. So I get x squared plus 16x plus 64 equals 36 plus 64. Okay, let's simplify this. So I'm going to use, I recognize this is a perfect square, so I'm going to use that technique in order to deal with the left-hand side. You can deal with the left-hand side either factoring or recognizing it's a perfect square. So let's see. This is a perfect square. This is a perfect square. The square root of this is x. The square root of this is 8. X times 8 is 8x times 2 is 16x. So again, perfect square. So I get square root of the first, sine of the second, square root of the last. Quantity squared equals 36 plus 64, which is 100. Next, we take the square root of both sides. So I get x plus 8 equals plus or minus the square root of 100. Again, that's really important. And from there, we solve. So x equals negative 8 plus or minus 10, which leaves us with negative 8 plus 10 is 2. Negative 8 minus 10 is negative 18. Okay? Let's move on. Okay, let's look at this. This is going to be kind of our last big example. So here's the thing. We can make completing the square as hard as we want, but for the most part, this is about as hard as we're going to see here. Okay? What makes this hard is, so far up to this point, I want you to notice, right, for all these ones, let's kind of go back real quick. The number in front of x squared was 1, right? Number in front of x squared is 1. So far, the number in front of x squared is 1. This number in front of x squared is not 1. So what do? Well, I've got a couple options. What I'm going to do is I'm going to factor out a 4 from both of those. Right? I'm going to pull out that factor. It's not the greatest common factor. It's just the number in front of x squared. I really want that number in front of x squared to be 1. So this is going to be x squared minus 2x. I'm going to leave a space right here because I'm going to be adding a c value to that side. Now, just to be clear, right? If you took this, multiplied to this, you get this. Take this, multiply to this, you get this. I haven't changed anything. All I did was I pull out that 4. Next, I'm going to look at this, and I'm going to complete the square there. So just kind of off to the side is scratch work. So I'm going to take this thing right here, and I'm going to complete the square. So let's figure out what that c value is. Well, that c value is negative 2 divided by 2 squared. So that equals negative 1 squared, or 1. Okay, so what I'm going to do now is I'm going to add that 1 to both sides. We're really close. Oops, I made a mistake though. Let's back up a second. So I said we're going to add 1 to both sides, but that's false, right? Now, I want you guys to pause this and just think about this for a second. Why? I did not actually add 1 to this side. I actually added 4. Do you know why? See if you can figure out why before I fix it. So I'm going to erase this. See if you can figure out why. Okay, I'm going to come back. Here we are. So let's see. Here's why I actually added 4 to both sides. So, whoops, I meant to erase that. The reason is, okay, so we found that c value. Oops, excuse me. We found that c value. We said, hey, it equals 1. But what did I actually add to that side? Don't forget there's a 4 in front of here. So this is actually right here, right? This is actually 4x squared. This is actually negative x, which makes this 4. So if I add 4 to the left-hand side, I have to add it to the right-hand side. Again, be careful. We said c equals 1, but 1's in that parentheses. That 4 gets multiplied to everything in the parentheses. So we actually added 4, not 1, to both sides. Okay, so let's see what we get here. Let's keep on going. I'm going to keep that 4, and I'm going to rewrite this. This is a perfect square. So let's see. Square of the first, sine of the second, square of the last, quantity squared, equals 6. From here, we're just going to follow the math. So I'm going to take, I want to isolate the thing being squared, so I'm going to divide both sides by 4. So I get x minus 1, quantity squared, equals 6 divided by 4. So I'm gonna leave that as is right now. So let's take the square root of both sides. So I get x minus 1 equals plus or minus the square root of 6 divided by the square root of 4, which is 2. So my final answer is this. Now, I'm okay with you just leaving it like this. We could write it as two things. We could say it's 1 plus the square root of 6 over 2 and 1 minus the square root of 6 over 2. But that really doesn't add anything to this. So we're going to keep it like that. Let's go through one more of these type. So let's just do B. See what you can do with B. I think it may, actually, let's do a little bit easier one. I think, no, B's fine. B's fine. So stop the video and see what you can do. Okay, I'm going to catch up with you guys. So remember, first thing I want to do is I want to pull out a 16. So I'm going to factor out of 16 out of that left-hand side. Again, I'm doing that because I want the number x front of x squared to be 1, right? So I had to divide it by 16. But if I did do that, I have to do it to both of these. Again, the right-hand side, I'm not touching. Let's figure out what our c is. Our c is not great. So our c equals b, which is -1 divided by 2 squared. You might be saying, ooh, that's ugly. That's 1/4. That's fine. You can get fractions. Again, this method always works, but sometimes it's just really hard. So let's figure out what we did. Now remember, c was 1/4, but I didn't really add 1/4 to this side. I really added 16 times 1/4, which is 4, which is actually, if you think about it, really nice. So we get this. Real quickly, if you're a little confused, I took the square of the first, sine of the second, the square root of the last. From here, we're going to get where this is going to be a little ugly. That's fine. Doesn't have to be pretty. I'm going to get 9 divided by 16. It's actually not that bad. Whoops, I forgot my parentheses there. Let's take the square root of both sides. So we get x equals plus or minus. The square root of 9 is 3. You may be saying, where did your 1/2 go? And I'm like, I don't know where my 1/2 went. Let's keep that. So we take the square root of both sides. We get plus or minus the square root of 9, which is 3, over square root of 16, which is 4. Okay, let me do that one more time. That was a little sloppy, and I don't want to confuse you guys. So let me do that one more time. If I wasn't lazy, I'd edit it out, but I'm lazy. So let's do that. So I take the square root of both sides. On the left-hand side, I get x minus 1/2 equals plus or minus. The square root of the top, or the numerator, is 3. Square root of the denominator is 4. And then we get x equals 1/2 plus or minus 3/4. This we should combine. So I get either x equals 1/2 plus 3/4, which equals 5/4, right? That's going to be equal to 5/4. Or, how messy is that? X equals 1/2 minus 3/4, which I think you guys would agree we can do that in our head. That's just -1/4. Okay? That's it. That's the lesson.